new, you know. Then I'm like looking, and there's so many events in Berlin. Like you can do it almost every day if you want to, you know. That's pretty cool.
Right. Going to wash my hands and see.
Aber willst du auch da arbeiten oder?
No, okay. Sorry.
Aber so interessant.
Oh, what is that? Coffee? Are you kidding? Plenty of coffee.
Thank you very much, everybody, for coming. My name is Tony.
Hi, I'm Red. Oh, yeah, you're right. Tall legs.
I'm the founder
Hi, Tony. Sup, Tony?
Yeah.
I think everyone here can understand English.
But online, then there's online also. I was thinking the same, but there's online. I don't know.
Right. Yeah. So, yes. Yes. So I'm the founder of JobCrypt, right? Blockchain's first decentralized job board on optimism. There are 3 others, but I guess they're not as big. So thank you so much for coming. Yeah, we really appreciate it. We are funded by the Filecoin Orbit program.
Amazing.
Whose mission is to basically drive the embrace of decentralized storage using IPFS and Filecoin protocols.
Oh, nice.
So, plan for the evening is that we are. Right. We're going to have a short workshop where I'll kind of walk you through JobCrypt and how you apply for a job on JobCrypt. It's a bit different from how you apply for a job normally. Because it doesn't just give you all the information. The website actually hosts all of the information on the blockchain and decentralized storage, so it's a bit of a different experience. But I'm sure that it's the type of experience which we will kind of evolve, make better, and basically transition into Web3, which is nothing like Web2. After that, at about 10 past, we'll have an amazing talk from Red.
Yeah, of course, it's amazing. Woo!
Who's traveled all the way from Frankfurt, beautiful Frankfurt.
Thank you, Tony.
Today, which will give you an introduction to
I hope it's amazing.
to,
Yeah, it's me.
blockchain.
I'm Red.
And so, in terms of the mini workshop, the main thing to understand is that you're not going to understand everything, but by the end of the evening, you will understand everything. So then we'll have done a really good job, even though we've kind of taught you everything back to front, but it's fine. After that, we will have Alfonso at about 7 o'clock, and he will take us through decentralized storage with respect to IPFS. Now, Alfonso is the guy when it comes to decentralized storage, so if you've got any good questions for him, he's the guy. That's all I can say. He's the guy. And then after that, we'll give you some information, further information on JobCrypt, give away a few t-shirts, and then it's kind of like you can network, have a chat with Red, and yeah.
Yeah, I have this. I didn't go to the toilets because I have the microphone. Until I saw I saw me in the mirror. I was like, yeah, it's coming. One of these. And then just need to wash my hands. Can I do that too?
No, go on.
No, I need to go to the toilet. So.
This is first.
It's okay. It's not connected.
No, thank you. Sometimes nice.
And the Zoom call we hear from this.
Yes.
So I put this for Presse
Okay.
to hear it for this.
Okay.
Then the speaker later.
All right. Come in. Welcome. Welcome. Help yourself to the food and drink. We've just started. Right. Okay. Is there anybody who'd like to? For the folks who want to listen to German, I'm going to post a link now. And I'm going to send it to all your emails, and that will basically allow you to jump onto the Zoom and listen to German. If that's okay. Yes. Before we start.
I send you the link. You can send the other.
Yes.
The link for streaming.
Yes.
Das gerade verschickt.
Ja, ihr habt es gesehen. Okay. Muss ich nur weiterschicken. Warum nicht einfach ein Discord posten, das ist schneller. Why not just put it also into Discord?
Oh yeah. Hello. That one. Okay. Okay. Are you guys on Discord? Yep. Okay. If you're on the JobCrypt Discord, if you go to the Munich channel, you'll find the Zoom there. Yep. Is that okay for everybody?
Discord.
Discord, yeah. The link to our Discord is on the JobCrypt.
Oh, there it is. Thank you.
I have to enter the email.
If you go to the JobCrypt website, there's the Discord icon. Just click that, and then you'll sign up, join into Discord, and then you just go to JobCrypt Munich, and the Zoom in German is there. Is that okay? Show you. Okay. Right. Okay.
Did you get my mail?
Yes, just got it. Right, there you go. Right, okay, so we're all there. Right, so
Was? Morgen habe ich gar nicht die Link gefunden.
Right. Okay. So this is a mini workshop. Yeah. Okay. Is everybody okay with translations? Oops, sorry. Oh, right. Okay. Totally forgot. Right. Everybody is okay with translations. They're good with language. Yes. Happy. Right. So the mini workshop is very simple. Right. Okay. What we're just gonna do is we're just gonna visit the JobCrypt website on testnet. He's on the Sepolia network. And the purpose of the testnet is basically going to show you how to quickly find a job, view a job, stake some tokens to enable application for jobs on JobCrypt, apply for a job, there's a test job there already, unstake tokens from JobCrypt, and that's the experience you'll have on the main version of the site. Thank you. Yeah, okay. So a lot of this stuff will be new to you. Let me just let our friend in here.
Excuse me.
Yes.
Which channel should we go?
If you go to JobCrypt Munich, yes, that's where you'll find all the information for everything that's happening here right now. Right. Sorry?
We have to go to that link that was just there on the screen, or?
So before that, there are a couple of things. There's a bit of housekeeping which needs to be done. Hang on. Here we go. Yes. I missed that introduction. So the first place you need to go is Sepolia Dev. If you don't have Sepolia on your mobile, which you might not on mobile MetaMask. I couldn't find it on mine, so I had to install it this afternoon. And then you've got to get some gas for testnet activity. Right? Now, the gas is free, but this faucet will basically just take your wallet address, which is the long number at the top, right? You just paste it in, and then the thing is that, it'll do the whole sort of like capture thing, and then the thing is it'll do some proof of work. So it's like 5-6 minutes or something like that, where it'll basically create some ETH, testnet ETH for you, right? Main thing to understand is that don't buy testnet ETH and always use the Sepolia network. If you use there's another network which you will encounter in your journey called Goerli, right? Goerli. And unfortunately, a lot of people and protocols use it. So the gas on there is very expensive sometimes. And some people are inclined to sell it. I don't recommend you buy it. I just say move to a cheaper network. Yeah? Okay. So, talk about super multitasking. Sorry?
Sepolia Dev and then?
You just click add the network to make sure you've got it.
Add to MetaMask.
Add to MetaMask, yes. Okay. And then once you've done that, you'll then need to go to the faucet. Yes. Yes, the faucet here.
You can open in a new tab or the same tab, or it doesn't matter?
It doesn't matter because the faucet just needs your wallet address, which is that long number you'll see at the top of your MetaMask underneath the circle. So you just copy that long number into the faucet, and then the faucet will run. Yeah? Okay. So you'll need to leave that to run for a little while, right? So what we're going to do is that we're going to continue this after Red's great talk to give the faucet some time to work, and then you guys will have some gas, and then we'll move the workshop on when you've got gas in your wallets. If you're stuck, just tap me on the shoulder, right? And I'll come and help you during the break. Is that okay? Fantastic.
The MetaMask thing is not working. Like I pull it and nothing happens.
Okay, I'll come and have a chat with you and show you how it works. Red, the stage is yours.
Right.
Thank you. Hello, everyone. So I'm just setting up my. There you go. Yep. Thank you. Sorry for the noise. It's not working. You can't hear me? Oh, You can hear me now? Okay. The volume is too low for her. You see my screen? Awesome. Okay.
Or maybe
You must speak
just like
in the
this.
top of the
Okay.
microphone. Not from the side, you didn't hear anything. You must speak and
Gotcha.
says to your mouse.
Oh yeah, it's not a SM58. It's not a cardiogram. It's like try to get you. Hi. Good evening. I'm glad to be here. This is super nice. Should I start?
Please, go ahead.
Yeah.
Yes,
all
yes,
right. All right.
The stage
Nice.
is yours when you're ready.
I guess I've talked the most to everybody here. That's pretty nice. So I see. I don't know if you're a blockchain developer. I usually ask the question, "Are you a blockchain developer?" Because they are rare people, I would say. So, and I know that because I started my company in Web3 for space. I'm PhD in robotics, and I worked all my life in the space industry. And then I worked at the European Central Bank for a bit, studying a bit governance and the impact of blockchain on the financial ecosystem. And now I created my own startup, Parametry.ai, which is focused on space operations and how blockchain could be useful in that domain. So what we're trying to do is like trying to break the industry status quo. So far in the space industry, everything is super expensive. It's a bit like in automotive we discussed earlier, and everything has to be done externally, which is a bit weird. And in the company right now we have 5 people, 1 robotized cluster, so I call the cloud that we own, and then we're building what's called Space DAO. I'll tell you later what this is. You don't have to know what DAO means or neither what space means, but that's what we are building. We are 5 people. We have no blockchain developers, but we're doing blockchain yet because blockchain is a distributed system, and as PhD in robotics, I knew that. So I'm taking people from distributed systems to work on this. But I went on the hunt to find blockchain developers. So when Tony was talking about JobCrypt, I was like, okay, this is a good thing. Yeah. Going to happen. And what I feel today is that it reminds me of the Frankfurt data science meetup. Frankfurt is where I live. In the beginning, where we were 10, now we're 5,000. So let it come. It's coming. Okay, this is my name. I worked at ESA, I worked at NASA, and at the European Central Bank. So I'm not afraid of your questions. So do not hesitate. Just hit me with the worst questions ever. Expecting that. I have tokens to distribute for the best questions. All right, since we're working on the moon on this, I wanted to first thank somebody here in the room for inviting me today, and I just wanted to feel the warmth of Munich. Show me how you applause like crazy when it's actually somebody's birthday today. Tony, thank you very much. Yeah. All right, thank you, Tony. Thank you, everybody. Yeah. Is that your birthday today?
My birthday is on April the 8th, same day as
Oh,
IPFS.
it's not today? Oh, sorry, everybody.
Don't worry, when it is,
Yeah.
it'll be a big bash.
Yeah, all right. So what just happened right now? So I just made a claim that was Tony's birthday. And what you did is like you uploaded, because, you trusted me via the system because I've been invited as a speaker, so you trusted me. But why? Why do you have to do that? You trusted me, therefore you took an action, and which was a clap, another clap. Each clap is 10 euros. How much did we spend today? On a fake claim. Not a fake claim. I was sure of it, It's just not validated. And that's what's happening in space traffic. So you have like many spacecraft in orbit from many different governments, and then you have many companies tracking where they are. And I remember Sabine is translating. And then it's just claims. We have companies claiming that, those ones are going to collide in 7 days. You could check that with another company. For now, we are trusting the speaker of the claim. So that's what we're working on, and that's why we're using blockchain as well. So we do offer front trainings at Parametry. I just wanted to say that in case you wanted to interact with us. We did some for the European Space Agency themselves, for lawyers. That was interesting to do that for lawyers, so I'm going to hit that. But also we did it for innovation officers in big institutions, so do not hesitate to ping me for those kind of trainings, not just blockchain, but a bit of everything in new technologies. We have ground experience, so meaning like we tried different blockchains. So Bitcoin, obviously we didn't do business on Bitcoin, we just, hacked Bitcoin somehow, gently hacked. And then at the end, more recently, we're using Multiverse X. It's very promising for us. The old name of Multiverse X is Elrond, for those who knows. And yeah, if you, there are many blockchains. I don't know them all, but I know the principles. In the end, in the company, we are space industry professionals, and that's what I'm going to talk today about, an application that we are doing for space. You're not going to hear me saying smart contract here, smart contract there, or anything like that, because it's not about that. It's about space. So in space, we have space systems. What are they? So do you know what this is? This is a spacecraft. And you've certainly seen that little man next to it. Okay. First time I came to Darmstadt, next to Frankfurt, to work at the operations center. I visited the next center, which is EUMETSAT, taking care of weather satellites. And some of them were very big, bigger than this one. Actually, it was bigger than my flat when I was in Darmstadt, which was just 2 rooms. So I was like, I could live in a spacecraft because it's a lot of empty things inside, empty space. But this one is called Sentinel-1. It's a spacecraft, you can say spacecraft. We call that a satellite. But the administration, the governance, the regulatory bodies, they call that a resident space object. It's in space, it's resident, it's an object. I have to pause. So those space objects, we have to launch them, right? So, but first we have to design them. So we have a team on the ground. We have a team on the ground that designed the satellites in the beginning. I was talking about that earlier. Everything is virtual. Then we are preparing the spacecraft once it's built, and then we are actually putting it on the last stage of a rocket. Here you can see actually James Webb's telescope, the latest one sent for observing stars, and it's actually folded in a very smart way because it's huge and it has to fit in the rocket. So right from the design, you actually choose the rocket because you have to design the satellite to fit that rocket. Once it's there, it's actually launched. So you have different stages in the rocket. In the last stage, the head is going to put the satellite in the right orbit, to the right place in space. And then what's happening? Space operations. Most of the life of the spacecraft is here. So here you see a room of, I guess, 10 to 15 people, depending on the busy days, managing the spacecraft that you've seen earlier, the orange spacecraft, called Sentinel-1. And you have spacecraft operators. They stay in front of the screens every day, looking at data coming from the spacecraft, trying to see if it's in good working order. And what's happening is that now companies, it's getting private. What you've seen is a room in the operations center, so it's a public institution. But you have companies like SpaceX sending a constellation called Starlink, and they're sending satellites 50 by 50. So the number of satellites in space is increasing. In the past, each mission was about 1 to 50 satellites. I count 40 for the GPS, 32 for Galileo, 32 for the GPS, etc. About that number. But then the future is more like the designs of those missions, 100 to 10Ks of satellites. It's a lot, okay? So we have an accumulation of satellite in orbit, and what's happening is that, we're starting to have traffic, okay? And that's an important traffic because it's representing 91 billion euros downstream business, everything. Just positioning, think about it. But then you have imagery. So imagery meaning that you actually manage the land differently, urbanization differently, agriculture differently, because you have insights from space. And intelligence, military guys, the green goes. Anyway, what I wanted to say is that there is space traffic. That imagine, the city without roads, no rules. You take the car, you go. When there's a crash, you don't clean up. But if you have a picture now, that's space. Okay? You get it. All right. So that's space. So there are plenty of things happening in space. You have 34,000 objects in orbit, including satellites, including dead satellites, including rocket bodies. You've seen the last stage of the rocket. You have like actually openings like the coiffe in French that just orbiting around the Earth for just 12 to 100 years. Depends where it is. And then you have other things happening because it's a free space. Space is a free space, meaning that many governments can use it. You have the tragedy of the commons happening. I heard like some of you are economists. So this is a space that everybody wants to use. So everybody has incentives that it's in a good shape, okay? That it's clean, free to go. But everybody wants it for themselves. So that's the tragedy. The zero-sum game is that the kind of business that we're having. We have companies that just want to take it all. So they just want to be the only communication company, the only Earth observation company. That's the problem we have. No collaboration on the business side. And then the prisoner's dilemma. So for managing the traffic, you need to know where the others are. If the other satellites don't want to know where to be, then they don't want to share their own information, but they want to know where you are too. So that's the prisoner's dilemma, more or less. Maybe you know better than me. So what's happening is that we have like so many things in orbit, a waiting list just growing. So you can see that, and it's thousands by thousands. And then you have, I'm not counting even the smallest ones, just the ones from Amazon, SpaceX, OneWeb, which is made by Europe, and the Boeing satellites. And it's just in 2022, we had 3 years to grow 1,000 satellites. In the last 2 years, we grow that rate, so it's just 1/3 faster. It's just going higher. Questions? You have a question? No? Okay. Yeah. Sorry, you can go back. We can go back to that if you want. Maybe. The thing is that then we have more things in orbit, so we have motivation to see what's happening in orbit. So we have a vibrant, what we call space situation awareness. So you want to be aware of what's happening in orbit. So you have an ecosystem of startups that are doing that. So here you see a lot of optical examples. And that's what I was telling you earlier. That's the claimers. The ones that claim, oh, this satellite is there, it's going to collide with that one in 3 days. That's Tony's birthday today. Yeah, it's not. I thought it was. And that's an example. So one of the company, I'm not naming the companies here, they are actually tracking the public data from the US government. And it's important. And what you have here, I'm just marking 2 satellites for the example. Okay, 2 Starlink satellites. And you see here, they are being launched. So you have like a queue of satellites because it's just early launch phase for them. So they are just getting farther from each other, bit by bit, to reach their final orbit. But at this moment, they're very close. So I have 2 satellites. And I wanted to compare that with another provider, which is actually the official provider of Starlink for the positions. The 2 same satellites. I was like, if I take only one, you will not see if they are before or after South America. And it would have just been a mapping problem and not a positional problem. But then I'm taking 2 of them, and you can relate. So this is Starlink 517, and this one 5127. And they're totally different places. Happy birthday, Tony. So this is serious. Serious differences, right? Okay. The date, that's the date I took the data from, okay? You can retrieve that, you can check it out. So just for the visualization of the differences, in orbit, the speed is 7 kilometers per second. Per second, yeah, it's like one is realizing. It's very fast. So meaning by the time of the talk, you cross the whole US somehow. And I just wanted to show you some stats on the average errors and the max errors on the TCA, what we call the TCA, so time to closed approach. So I'm saying, okay, your birthday is 1st of March. How close am I to that? You know, that's the error I can make. And the missed distance, so meaning that you're doing your birthday here and I'm in the next room and he's in the next building. So that's a big error, sorry. I had to take an example. So TCA is on average 7 minutes. What is 7 minutes? I put it in little here. It's crossing France and Spain. Okay, it's between Paris and Sevilla, I guess, if I'm correct. The max error is 14 minutes. It's crossing the whole Amazonia, so in Brazil. Yeah, you start to realize the problem. And the missed distance is on average 400 meters, and max like almost 1 kilometer. So in space, it's very small. Those numbers are very small. So in space, you're managing risk, okay? You're not avoiding collisions, you're managing risk. Yeah, Dominic?
Distance, you mean the distance between the satellites?
Yes, exactly. So, and you have also like the distance between the bubbles around the satellites, the safe bubbles. So you want that number to be big, you know, like so you don't make a mistake because you know that the data is as you can trust it like that. Yeah. Not saying that. As best as we could. Best effort. So what we're doing at Parametry, we're building a Space DAO where we have two phases. First, we are collecting the data from different providers. You know, different startups, different institutions, everybody. It's like a big joyful party. Then this data is called CDM for conjunction data message, but it's not important. Just remember CDM, that's the source data that describes the conjunction, the collision. We're collecting multiple of them, and then what we're doing is we're matching them. So we're using a bias approach, so meaning that we have a model of each of those providers, how much we can trust them, and this model is going to evolve. It's going to be recorded and evolved. And the output of the fusion is that we have a consensus. So meaning we have one CDM. We say like, okay, this is the best that we can get from all what you tell us. Okay. So if you say 3, you say 5. This would say 4. You know, somehow. You get it, like because I took an example where average made sense. Then you have a feedback loop. So meaning that you say, okay, you said that, but the consensus is that. So how far are you from the consensus? Are you totally like making a beer, or are you okay? Are you in the game? And that's what we update. So here's just like capturing data and making a consensus out of it. And then if you have more trust or confidence on that data, then you can take decisions. Let's make a party for Tony. It's tomorrow, by the way. Yeah. I need more input. It's just me here. So we're taking that consensus, and then we are entering phase 2, so negotiating actions, okay? So we are automating the business of negotiation. So for doing that, we need the metadata, so meaning that do you have a big or small satellite? You know, how much can you move if you're in orbit? So if you have a big satellite, you know how much power you need to move a truck. It's the same thing in orbit, so. And then negotiation contracts. So maybe you have a satellite, I have one, and we already have a contract, meaning that every time we enter a conjunction, I tell you it's fine, I'll move. No hard feelings. Yeah, I'll move. And then at the end, at the output, you have the identity of which one should move. Okay, if that's a simple contract like we have, that's fine, we know. If that's a more complex contract based on rational calculations, then you have to wait for it, and then it comes. We could also build a consensus here, but this is not really the focus of our project right now, because now we're just giving that to operators. So we had a better information, hopefully, consensus, and then we are automating the business logic to have a higher level of decision and say, you have to move. Because the operators now, if they know they have to move with more certainty, they're okay to work on that. It takes a lot of time to move a spacecraft sometimes. So a clap 10 euros, moving a satellite, 7 days, 5 people with high pay grades. I let you think. Yeah. And that's what they see. So in the end, they have a dashboard where they see their spacecraft, the other one. They see the result of the consensus. They have like transparency on what happened during the creation of this. And that's what we're providing right now. So, but this is just the prototype part. This is the output of a project, an innovation project we did with the University of Strathclyde for the European Space Agency. And we're moving on further. So right now, as a company, we're part of a mentorship program. We're moving on further with nice mentors and connections, and business support. So that's good. And yeah, we're really doing business automation in the end. And so, as you've seen, I put phase 1 is risk assessment. Phase 2 is action negotiations. And I talked about space until then. But what about Tony's birthday? You know, we could do a risk assessment. So what is the risk if it's not today or tomorrow, whatever. And action negotiation, you organize it, I do it, or whatever. That's not too obvious, but think of healthcare. So you go to one doctor. It's painful. You need a surgery. What? Okay. Then action negotiation, which surgeon take it? But my risk assessment was very weak, so meaning I just went to see one doctor. What the hell? It's just a human being, can make a mistake, right? So all this, we put it in an ecosystem where we're actually putting rules and governance rules so that people can actually adapt the system when it goes, because we are not believing. We have a throughput vision, and we can organize everything from now till the end. We know things are going to move on. It's like blockchain technologies in general. Yes? Go ahead.
Okay, you're doing risk assessment over actually some consensus models, over models that actually were themselves the product of actually doing risk assessment of the individual. Because you're building models and you're doing some simulations and various things to sort of get an idea. You have actually models that may be quite different, and actually consensus models sometimes work, but actually very often they won't, because they have different feature points and different various things, and you may be shooting yourself in the leg.
Yeah, totally. So if I rephrase the question, like summarizing, maybe I hope you don't hate me. You're saying that the consensus mechanism we're proposing might shoot itself in the leg at some point. If I summarize like that, that's just reconnecting exactly to what I said, is that we don't believe that it is the right one. So yeah, that's why we have this adaptable governance, so where people can vote on, hey, what about we use another algorithm? Why not? Yes, let's vote and let's try it. And you can actually have things that run in parallel. So that's the thing we discuss with industry, and sometimes that's why we have several contracts for negotiation, because we can't say between he and me it's fine, between he and me it's different, maybe it's still fine. But a good question, yeah. Thank you. So why blockchain in the end? So you may think, because we don't need blockchain to do that in the end, okay? But the problem is that we want this to run autonomously, so we actually need decentralized identity. So somehow we don't want to have a counterparty which is a single point of failure or of control of who is who, somehow. We want a secure ecosystem, so meaning every action we do, we need to have those signatures and encryption made of, so it will be there. And we need to currently distribute information so that we actually augment the trust, so meaning that if you have information, I have it, I can check yours against mine, etc. Because I know the algorithm that is working to do that coherently. And that's just, a pedigree of technology that blockchain is using. So, when we talk about Bitcoin, Ethereum, or whatever, it's like an ensemble of algorithms, an ensemble of technologies that are integrated together to do those things. And this is like 3 big categories I highlight general, and that's, instead of redoing the wheel, we actually look at the blockchains and reuse them somehow. But we reuse the protocols, not the public blockchains. And we had that problem, that when talking with people who actually don't know much about blockchain, when we say, oh, we use the blockchain, the Ethereum blockchain, we actually use the Ethereum protocol. And we don't use the Ethereum blockchain because this is the name of the public network, and people associate that with the public network. And I had problem like understanding that in the beginning until they asked me, is my data public? Or okay. So key takeaways, yeah, as I told you in the beginning, like blockchain developers, I try to look for them. It's good if you're a blockchain developer, but we are living a time where this technology is starting, so you don't need to be marked as a blockchain developer to do blockchain, so just go ahead and try. Definitely my advice is that you need to know about distributed systems. You know, if you don't know about distributed file systems, it's going to be harder to understand blockchain itself. And encryption as well is useful. For large institution, and ISA was very honest about it, they wanted to know how to increase their visibility and trust on a technical domain that they don't know. So meaning that they are confronted to blockchain and they're like, how could they trust a provider that is doing blockchain if they don't know about blockchain? You know. So what they did is that they actually increased their visibility by doing internal training and everything like that, and that's good. Another key takeaway, just join communities. This is the moment to join communities. That thing is that the entropy is so high that the things happen in communities, not at school, not at university yet. So that's the thing. So it's, you know, those kind of communities, that's where things happen. So if I had to summarize our vision, and this is the first QR code. This is my team is expecting that we get 100 followers on the web page on LinkedIn. I get push-ups for every non-followers. We have push-up tokens in the company. I'm trying to have a DAO. I'm tired of being a CEO. Gather a global community of space actors and build a global collaborative network. And so we offer space interoperability across different governance, whatever it has rules actually. So that's what we're doing. So thank you, and yeah, the winning game for me is like if we build that collaborative network and if you want to hack it, you have to act good, and that's perfect. I start to see companies, they're like, oh, you're doing that? Okay, we have to collaborate with that company and that one, you know, so we don't have to use you. That's perfect. If you collaborate, more consensus, good. So please, yeah, get in touch. Be very happy. If in case you wanted the QR code before, it's here. It's also here, or here. Yeah. Thank you. Thank you. Right. Question over there.
I have another question.
Yeah.
In this particular case, you actually have a well-defined collection of actors. It's not a terribly massive number of actors participating. You're talking about actually a distributed federation. None of that actually requires blockchain. In fact, it's counterproductive. You don't need immutability. You're actually collecting data in various times, and you can store that in other things, which are much more efficient. Why not go that route?
So that's good, yeah. Why not is that because we believe that we still want to remain open. So even if stakeholders are identified, we never know tomorrow what's going to happen tomorrow. And we don't want to be there to identify them. So we want the network to identify them. We don't need to, you know what I mean? The other thing is that we are surfing on innovation grants, so we are exploring. So we might be agreeing with you, like at some point. We are actually developing things that are not using blockchain, trying to do the same thing. So that, yeah.
How are you going to prevent, for example, since if you're using actually a DAO structure, how do you prevent, for example, bad seeds playing the roles of good actors? For example, certain nation states that want to dominate are basically polluting and poisoning.
So yeah, I see what you mean. So the question is that if we build a DAO, like a space DAO, how are we preventing from having bad actors polluting the network? Malicious network.
They have their own national interests.
That's, yeah. Everybody. So as I told you, like you've seen the big map with the, I guess the big sphere, is that we don't believe everybody is collaborative. So meaning that we have all this happening. So we want to take that into account in the governance. It's a non-cooperative game, that's for sure, yeah. So we're just being the interoperability layer between those people because they have to. In a collision, you have to interoperate. If you don't, you interoperate the bad way, but that's, yeah. Yeah. Sorry? Intentional intelligence. Yeah. Well, happy to discuss about that after one. Yeah. Definitely. Yeah, go ahead.
I like the way you want to integrate trustless, like the trustless idea into what I see at least. And but I do have to agree that you're looking for people like space people. When you go into the slide, like the second to last one, slide on your on your talk, it's like we want some people here. We want space actors. But like if I'm not a space actor, I can still be part of the DAO, right?
Why? How?
Can I not as like?
No, yeah. There are like there's an identity system, so you have to be you have to prove you're a stakeholder, and that's good that you point that because I guess that would also like clarify behind you. That's what are space actors? So I put space actors here because it's like very global. It's like saying stakeholder. I say stakeholder all the time, every day, and people are like, who's stakeholder? For me, it's like operators. You have the people on the ground, like monitoring space. So like just engineers, laser engineers, optical engineers, whoever. You know, it's almost like everyone in the end. And then you have a regulatory bodies, so lawyers that are interested in regulating space. You have economists as well because there's an economy impact. So you want to know if what kind of rules of space traffic you have to apply. And actually, the space policies are being taken care of by the economy offices of the space agencies. So that's a lot of people, different backgrounds, different profiles. So I agree with you. Like we don't really need like full trustness, so like being fully public. But this is so varied that we don't want to predict what's going to happen there or like force it to be somewhere. That we just use. It's a private blockchain in here, so it's not public. Yeah. Oh yeah, that's nice. Thank you. Thank you. Well, do not hesitate to chat. I mean, those questions are. I mean, I love to have them. That's the kind of questions that put me in the corner and put me in the reflection. So do not hesitate. Also, if you want to work for space on blockchain and Web3, and keep in touch. Thank you again. You want this?
Fantastic. Thank you so much, Rich. Right, now we are going to have a bit of a short break while we get ready for Alfonso's delivery. And yes, we're going to have the continuation of the JobCrypt workshop. So please rest and relax, and I'll call you back in about 5 minutes. Thank you. Right, there you go.
Right now there is a conference.
apricot, 70 grams. 70 grams per second. It's a truck, 50 kilograms per second. 18 tons.
Calculate that is
Yes.
6,000 kilometers per hour.
Yeah. In terms of energy, it's like the apricot, you shrink and compress the truck, 18 ton trucks in the apricot, and you just throw the apricot at 50 kilometers per hour. So you have to imagine you're in front of the truck, you try to stop it.
But does it crash off?
Not that often, hopefully. Sometimes, yeah, but also like sometimes they just do sats on the side and missiles. So they're sending missiles. The problem is that thing exploding in mostly there's a
Right, so the point is that there's lots of information federation in terms
clouds
of
of
natural
debris
resources
that
that go
are
on.
occupying a large kilometers in space, and then they continue orbiting. And then they're spreading, and then they're all around.
I was just a week or so ago in Basel,
And then the International Space Station comes in.
settlements.
All the concept of space.
You know, and I'm saying, think of international settlements, all the central banks in the world are part of this thing. They do also risk analysis, but
Because the Soyuz
again,
module
these various
was
players,
built
they have their own interests, it's not cooperative stuff in the banks.
by,
And in terms of
I would have
space,
my
it
own
works.
So the module in the US module in the space station, they have like
even if I
shields.
Well, no, but see, it's a general point, you have, for example, a number of, give this,
there's a lot of
Medieval.
people or
But it's,
well, no, just imagine, a lot of Chinese space companies
to claim the
can join the DAO, can get
So yeah, that's a good point. So
very
the
high
thing is that
level
on the
state,
on the
and
network
can
we're also like
intentionally,
identifying not just
poison
the
things for their own
the
gain.
objects.
Because remember,
People are already identifying this is
collisions
a
of
debris, big
satellites
debris from the
is not
cosmos
always
mission.
an unwanted
So
thing.
they know they can. The insurers might be interested in that.
You can do all kinds of things, considering the fact that there is this territorial,
Okay.
Land
Claim is from this guy.
and at the same time, we have a problem, you know,
But there's
is
not
that,
no option to collect the
there
trash.
is, you know, it's a bit like, you know, people are talking about having drones delivering products, and that works fine as long as there are only 2 or 3, right? But then after a while, you know, I mean, why do we, you know, we,
drone manufacturer, I would manufacture just one-time bullets.
right, but one
For
of the,
$1,000.
right, but even that, that's, the problem is it doesn't scale, that's the problem actually, you know, within space, is it does not, it doesn't infinitely scale, and we have right now a situation where the cost is going down, and so everybody and their grandmother is basically shooting up satellites, and it's all garbage.
Right. Thank you. So, has everybody got their gas?
No,
No. I'm talking about blockchain gas. Yeah? Not the other type of gas. You can keep that gas. No food for that. Anyway, so we've just got Alfonso, who is now on the line. So we're just gonna tee him up. So if anybody's got any questions about how they get the gas for their Sepolia, now's a good time to ask. And then we will basically continue our exploration of using blockchain on testnet after Alfonso's fantastic delivery of decentralized storage, which is...
How much do I need?
Sorry?
How much do I need from
Not a lot. About an hour's worth of work, which is just, I think, probably what you had, just enough.
No, because I just started like 5 minutes ago.
Oh no, that's fine. By the time the talk is over, you should have more than me.
Okay.
Yep. Okay. Great. Any questions from anyone? Okay, fantastic. I will now hand you over to Alfonso, and yeah, let us enjoy decentralized storage. Thank you.
Oh.
He's speaking, yes. Can we hear you? second. So it needs to be plugged into some sort of audio. You want to try now?
Huh? Don't work.
Yeah, we can hear you. Okay, awesome. Can you give me rights to share my screen? For some reason, okay, give me a second.
Ach ja.
Okay, now it works. Thank you. Cool. Sorry about this technical. So thank you, Tony, for inviting me. I'm really sorry I cannot be there with you. I would have loved to be there and like at least see your faces and get your questions. Yeah, and today I'm gonna welcome you all to Web 3.0, and I will share a bit about like decentralized storage, IPFS, Falcon, and we're gonna discuss something more apart from blockchains and can you hear me? No? Okay. Hear me? Sorry. 2 seconds. 2 seconds. I think I hear myself in the room, at least. Let's see how we get better audio. We're going to discuss something more apart from... Better? Give me a second. Do you want to try now? Okay, what about now? Is that better? Better? No, it's that much better. That's a maximum. Do you have this on both sides, so we can plug into there? No? Oh, there it is. Hmm? I'm going to try and put it there. But probably not going to help. Let me try this.
Aber das andere ging doch zuerst aber so ein bisschen besser.
It's echoing back, but what do we need? Let me know when you need me to speak. Yeah, no, that's okay. We're just trying to amplify the sound. Let's see. Yeah, what? Ja, den Ding ist ein bisschen gegangen, wo die jetzt nicht. Okay, I guess we've got it. We're on the right track, don't worry. Right, okay, so let's see where we're at. Where's my son? This is not what I'm looking for.
Probably turn off the microphone. He doesn't need it anyway, since he's talking.
Yes. So.
Should I just plug it off?
Hmm?
The microphone?
Oh no! It's here. He's coming from here. Yeah. Ah, right. Okay. Now, no, you can't. Now, do you want to try and speak?
This is really high now. If the
So-
microphone is disabled, you can increase the volume up to where you want it without basically.
What's it done? Jesus.
Should I
Right. Give me a second. Okay.
Okay, so let me know if it works. Yes, no? Okay, cool, thank you. So I could keep talking until someone says otherwise. Sorry about like these technical issues, and thank you for all of the effort you're doing in order to let me chime in and do this talk. So yeah, really briefly, so that I don't waste more of your time. My name is Alfonso. I'm a research engineer at Protocol Labs, and I'm currently working on Filecoin and other open source projects within Protocol Labs. And specifically, I'm working on Consensus Lab, trying to scale the consensus layer of Filecoin. And what I want to do today is introduce you to the Web3, justify why we need decentralized storage, why we need content addressing as one of the key pieces of the new internet. And yeah, hopefully after this, you're really excited to start building on top of Filecoin and IPFS. So first I want to introduce, and I will try to convince you of why I think, and many others think, that the internet is currently broken. So this is the Web 2.0 we are currently used to, where we see services like Netflix, Facebook, LinkedIn, so the kind of services that we use on a daily basis. And the way in which we interact with these services is that we go to the web, we upload information, we consume information, and it's an interactive web. But sometimes we see these screens. So more than we will be willing, we see these screen where it says that we can't access one of these services that we really rely on. Actually, a good example of this was this morning where GitHub was down. So this happens quite often. And like the reasons why this happen, they can be diverse. But one of the reasons is because of the architecture of the internet. So you may recall one of these huge outages that happened a while ago, where Facebook advertised the wrong prefixes to its peer autonomous systems, and it made half of the internet to go down. Or other examples where we had like CDNs like Fastly, where because of an outage in their infrastructure, they couldn't, like, many of the services couldn't be accessed because all of the assets that the CDN that this CDN was providing weren't accessible. And like Slack was down, GitHub was down. It was crazy because a lot of our of the services that we use on a daily basis were down. And one of the reasons why this happens is because of this. So this is a high-level architecture of how the internet works today. And so whenever we want to use one of these services, what we go is to our browser and like we type something like this, like http example.com/catpng if I want to get the picture of my cat. This is translated into the specific location of where the picture of my cat is in the specific server that it is located. So what happens is that usually all of these locations are in the backbone of the internet. So I have to, from my device, I have to do a bunch of jumps, and I have to follow a path up till the resource, like the location that has the picture of my cat. But what happens if one of the critical infrastructures or one of these like important steps to reach the picture of my cat is down? Well, because of how the internet works right now, where we're searching for content according to its location, we won't have a way of fetching this content. Even more, like sometimes we consume content that is popular in our location, which means that maybe some of our neighbors or some of the devices that we have close to us, they already have that content. But because of how the internet works, where we actually go to a specific location in the internet, there's no way for us to get this content. Even like the case of Fastly, for instance, where the CDN is only providing static content to load a page or load a web an application. And even if someone around you is using those same assets and you could pick them up from them, theoretically, because of how the internet works, this is not possible. So this is not the only problem. We have another problem, and many others, but like another big problem is the inefficient use of bandwidth, right? Because, for instance, let's imagine that all of us want to, okay, I'm not in the room with you, but like imagine that I'm in the room with you and we all want to load the Gamla style video. So I said that content is accessed in the internet through a specific location, and usually this location is in the backbone of the internet or these big data centers that Amazon and Microsoft have. So this means that we have to do a bunch of jumps in order to get to the backbone of the internet and get the video back. And this happens for all of us. So all of us that are trying to download this video will follow this path and download the video. This means that a 200 megabytes video, if there's 30 of us, for the 8 steps or the 8 jumps that we have to make, it will be translated into 48 gigabytes of bandwidth that the links between all of these devices have to use. When actually, if we were able to find the content in our surroundings, maybe it was just 1 or 2 jumps what we would have to do, and we wouldn't be loading that much the links between all of these devices. There's another interesting story here, like if you recall COVID. So I don't know how it works in Germany, For instance, in Spain, we didn't have that many outages of the internet with lockdowns. But in COVID, what happened is that many people stopped being in the offices and they were consuming like a lot of internet content from the residential areas. And so in some countries, what happened is that these, like the internet infrastructure was not deployed to support that amount of traffic. And there were a lot of outages because of this, because everyone was in the same location and was trying to fetch the same kind of content from somewhere else, and it was loading a set of links that they weren't prepared for that amount of traffic. So this is another example of how the current architecture of the internet and the fact that we try to find content through its location, it's harming the internet overall and the infrastructure. So I shared in detail how like the problems with disconnection, the problems with bandwidth, but there are many other problems that I'm not gonna describe in depth. For instance, the offline first applications, many, like almost all of the applications that we use right now, they require some kind of internet connection, and you may probably have experience when you're in a plane that you cannot use many of the, so a lot of information is cached, but you don't have a way of communicating either with the people that are within the same plane. And this is a problem because we were used to this setup where everyone had desktop applications and we could like at least do some work and then sync it to the internet. And right now, like many of our applications like take the internet for granted and they're not ready for an offline first situation. And again, this is because of the, so a good example of this is messaging apps. Every time that you want to message with someone that is in your same room, you have to send a message to the WhatsApp infrastructure or whatever other application you use, and back to the person in the room that you're looking to send a message to. While if we changed how we architect the internet and how the underlying protocols work, we would be able to do these message and send this message one-to-one directly to the other device that it's in our room that we will communicate with. Another big example of something that is broken with the internet is permanence of websites. So there was a study that said that the average lifetime of a website in the internet is of around 6 months. And again, this is something that you've probably experienced because at least it happened to me that you bookmark some website to read it sometime from now or just for reference. And then you realize when you really want to go to that content and like consume that content that the website is no longer there, either because like the URL changed, the domain name changed, or because like the hosting that was behind that or the operator that was behind that website decided to take it down. Again, another problem of location-based internet instead of content-based internet. So if what we bookmarked was the actual content or the link to the actual content instead of the link to the location of that content, what we would be able to do is that we would be able to access the content as long as it's available in the network. And then we have some other problems, like for instance, security. The fact that so phishing, it's a perfect example of something that happens because of a location-based internet. Because if we could authenticate the source of the content that we're receiving and the website that we're loading, we wouldn't have this problem with phishing, where actually like some slight code changed. So the website seems the same, but like the backend you're interacting with, it's different, which means that you're leaking some information or some passwords. So having location-based, so having content-based addressing instead of location-based addressing, as we may introduce in a minute, allows you to avoid by design some of the problems of the internet, some of the attacks of the internet, like phishing. And then finally, we have some examples like IoT. I mean, having a content-based internet would be also really useful for IoT, because that would mean, like in many IoT setups, you're sending all of the data that you're collecting to the backbone of the internet and then doing some processing and back, when actually you could do some processing in the edge and have protocols that interact between the devices, and then you only communicate with backbone internet, with the backbone of the service when needed. And finally, control. If we have a decentralized infrastructure for the internet that is content-based, even if like a big country like Iran blocks the internet, and this is an example of when the internet was blocked in Iran, like you can see here all the traffic that it had and how it completely stopped. even if the access to certain regions of the internet was blocked by either the ISPs or central government, there will be a way of fetching the content as long as it's available in our surroundings. So we see that there are a bunch of, I don't know if I convinced you that the internet is broken, but at least there are a few bugs in the internet that we could fix, that could be fixed. And the idea behind IPFS, Falcon, and these decentralized storage protocols is actually upgrading the web. So there has been many proposals in academia of like alternative ways or alternative architectures for the internet, but like the fact that you have to go from what we have now and try to like break it down and start from scratch, it's not possible because that would mean some kind of outage. So that's why these kind of protocols of decentralized storage, what they're trying to do is actually upgrade the web. So put in place a set of protocols on top of the existing internet that would allow us to do this a more decentralized infrastructure, having this software first, having permanence, like having a set of protocols that will allow to make applications safer and smarter and also faster. I could like dig deeper into why is this, but like yeah, I'm not gonna spend more time like ranting about why the internet is broken and how it could be fixed. And actually, like you may realize by now that many of the problems that we have with the current architecture of the internet is that we go from a name, like from like typing example.com/ the picture of my cat and having to go to a location, to actually, instead of translating this URL into a specific location, we could translate it into the unique ID for the directory or for the content that we're looking for. And this really simple change, it can like make things way better. Because for instance, like let's take the example of the bandwidth use or the disconnection. So when we're trying to look for a specific location, what happens is that if one of the links towards that location from my device is broken, I won't be able to fetch the content. Well, when we're trying to look for the unique ID for the content, what we will do, or what the protocols do under the hood, really high level, is they shout to the network and say, hey folks, let me know if any of you have this specific content. And then you download it and you would be able to load the application. So the key idea behind this upgrade of the web goes from the like having a location-based architecture for the internet to try to have protocols that are content-based. So that instead of trying to fetch content according to its location, it tries to fetch it according to its unique ID. So we're moving from HTTP, that is location address, to a protocol like IPFS, that is content address. So what it tries to find is the unique, any content in the network through its unique ID. And IPFS is one of these first proposals to have a decentralized storage network based on content addressing. There are other proposals out there of decentralized storage, but of course, working at Global Labs, I'm biased, and I'm going to introduce IPFS and Falcon. And you can think of IPFS as a decentralized storage and delivery network that is based on content addressing and peer-to-peer networks. This is really important. So in IPFS, storage is not incentivized. So IPFS is a best effort network, and there are services on top of this network that gives you like the SLA and the permanence of content that you want. But IPFS is a best effort network based on peer-to-peer networking, content-based addressing. That is, it's focused on the delivery of content, right? So there's no incentive on storing. Like when someone in the network doesn't want to, is not interested, or anyone in the network is interested in certain content, it will be garbage collected if there's no one behind trying to worry about that content to be there. But then, so this is IPFS, but then we have Falcon. And Falcon, it's a completely independent network from IPFS, but it uses the same stack, meaning that it uses the same kind of protocols. So you'll see that many of the protocols that IPFS use for file exchange and for content addressing, for networking, are also in place in IPFS, so in Falcon and in IPFS. So they can interact with each other. They are different networks, but they have a way of interacting with each other. And in Falcon, like it's a different network in nature because IPFS has no blockchain, right? There are no incentives, and it's the best effort peer-to-peer network. But then in Falcon, what we do is that we take the stack from IPFS and we plug in a blockchain so that we can build an incentive system in order to incentivize storage. So in Falcon, storage will be incentivized. and users will be paying through this blockchain system in order to keep their information stored in the network. So this is the difference between IPFS and Filecoin, and this is you can think of IPFS as the CDN, like the read access memory. So it's really fast, it has access to the content, and as long as the content is there, you're able to fetch it. And then we have Filecoin, that you can think of it as the read-only memory or the hard drive, where you know that it's reliable in the sense that you know the content will be there if you store it there, but it may be slower to fetch the content from it if there's not a hard copy in the network. So these are the difference between IPFS and Filecoin, and what they are trying to provide in a decentralized manner. So with Filecoin, in the end, what we want to make is a free market of cloud storage. So the idea is that in order to compete with these big data centers that currently run the internet, they require a lot of investment in infrastructure. So, and actually, if for instance, Amazon wants to grow its footprint in order to be closer to the users, it needs to invest on deploying a new infrastructure and deploying a new data centers. While with Filecoin, what we do is that the idea is that if you aggregate all of the demand of storage that is out there, it can be like someone at home, it can be small data centers, it can be anyone. So, or some specific data centers, and this has been the case that deploy our infrastructure to be used in Filecoin. What happens is that you manage to aggregate with a huge footprint a lot of storage that you can commoditize and in this way compete with the huge amount of storage that other providers are giving, but delegating the investment into all of the participants in the system. And to give you a sense of what scale has Filecoin right now, this is the storage capacity. I mean, this is from, I guess, the beginning of the week. This is the amount of storage that is provided in the network, so that is ready to store any kind of content. The latest numbers that I read is that around 1% is currently used, so there's a lot of storage to use in Filecoin, and it's provided by around almost 4,000 service providers. So the service providers are the ones that are providing storage in their infrastructures and getting paid for every content that they store from users in the network, and they also get subsidized for the amount of storage because of how the blockchain in Filecoin works. They're subsidized for the amount of storage that they're providing to the network at each point. So in the end, we saw that IPFS it's a decentralized storage network that doesn't have any kind of incentives. It's best therefore it's used for a lot of applications, but you have to worry about the content being there and put some means so that it in order to make the content be there. And then we have Filecoin that by plugging in a blockchain, what we're doing is that we incentivize the storage of content. So we actually pay service providers to keep their storage available, and in this way we aggregate the infrastructure of a lot of providers and manage to get this huge amount of storage demand that you saw in the previous slides. And this is not science fiction. This is something that you can use now, and there's a booming ecosystem of applications that are already building on top of IPFS and Filecoin. Here are some examples. You have, for instance, databases or data-specific applications that are being built in a decentralized manner, like, for instance, OrbitDB, which is a decentralized database on top of IPFS. We have examples of social media applications that are being deployed over IPFS. We have decentralized proposals for instance, applications like YouTube that are built on top of IPFS or Filecoin. What else we have here? Then we have more Web3 blockchain-ish applications, like, for instance, for governance, to handle NFTs. There are a lot of NFT platforms that they store their NFTs, so the actual NFT in Filecoin and IPFS. This is a really so last year it grew a lot, and what happened is that there were a lot of applications that were minting their NFTs in Ethereum, and then they were storing the actual content, so the actual NFT in IPFS, so that it could be retrievable in a content-addressed way. And then we have some decentralized examples. For instance, this is a really cool application. It's called Anytype. and it's like Notion, but built on top of IPFS. We have Skiff, that it's another example of a decentralized, like a privacy-first email and kind of Google suite. So you have your docs, you have your drive, and so on. So you can see that there are a lot of applications that are already trying to build on top of this decentralized storage. And as a user, you can either like use any of these applications, or you could even like download. The ones that have a better support right now are Brave and Opera, but also there are extensions for Firefox and for many other browsers, and you would be able to fetch content from IPFS from your browser. And I will give you an example of this because I have Brave, and you see that here I just went to research.protocol.ai, and Brave automatically detected that this is a website that is on IPFS. And if I click this, it would fetch the website through. I hope you see these small letters, but like it fetches the website through its unique ID. So you see that this is an example, like this Protocol Labs research website is deployed in IPFS, but actually if you go to many other, once you download Brave, you realize that many of a lot of websites that probably not the ones that you use in your day-to-day, but a lot of websites are deployed on IPFS. So here we have Flick, that it's another, it's kind of a platform as a service. So it's a way of deploying your websites on the Web3, like on IPFS, Infinity, Internet Computer, so a lot of decentralized projects. So it allows you to deploy your application here, and it handles like all the interactions. And the landing, like this page from Flick, is deployed on IPFS. And again, like if we go to click that IPFS button, it will, like Brave will fetch it through its unique ID. So this was just to illustrate how you can actually load content that is deployed on IPFS already through your browser. Yeah, and this is what I have here. I mean, I'm using Brave. The one that you just saw is Brave, but like Opera also includes native support for IPFS, so you would be able to do something like this, IPNS : // and you will be able to get something that is in IPFS. And if you want to use Firefox or some other browser, there are extensions that will allow you and give you this support, so that, for instance, if you do like IPFS // and yeah, here I have an example, it will automatically translate into, like, here what I'm doing is just IPFS / and like the unique ID and then the specific content for that directory that I want to download, and you see that it loaded automatically this website. So the same way that I can access a website through HTTP, I would be able to access it through IPFS. Next. Sorry about that. Okay, we're back. Oh, and like there are other, for instance, this is an example of another cool application that is deployed over IPFS. This was promoted in part by Microsoft. So Microsoft and many others from the Decentralized Identity Foundation, they're trying to build a proposal or a set of standards for decentralized identity. So a way of like having a single digital identity that can be shared by several applications, several protocols, the same way that currently we use the Google sign-in or the GitHub sign-in for everything, and they're using IPFS to store like identity-related information. And they even have proposals to build over IPFS digital hub, so that you have all of your digital information in IPFS and accessible, so that you can handle the access rights to your identity and to your content. So this was an example of all of the cool projects that are already deployed over decentralized storage. This is a really huge effort from a lot of people, and all of these protocols are open source, which means that, I don't know, if you want to build your own alternative to IPFS or improve the protocol, or you want to build some kind of peer-to-peer protocol on top of some of the stack of IPFS, you will be able to do so, because all of these projects that I just mentioned are open source. And with this, I want to like also give you a brief overview of how we went from like the internet to these Web3 that we're trying to build, because every time that we talk about Web3, it seems that we are only talking about blockchains. And actually, if you use Ethereum, you'll see that one of the main libraries to interact with an Ethereum node is the Web3.js library. But actually, Web3 is way more than blockchains, because at the beginning we had wires and networks. That was the internet, and it was a bunch of universities connecting a bunch of cables and interacting with themselves, between themselves. Then we got the Web 1.0, where in the 1.0 what we had is only read-only access. This meant that the people behind the websites, they would upload their website, put it available for everyone, but they were static website, and we had static access to the web. This means that whenever someone wanted an update in some application or some website, it would have to call the operator and ask for that update. And then the one where we're immersed now is in the Web 2.0. And in this web, what we have is read-write access. So this is the interactive web where we have Spotify, and we can upload music and consume music. We have Netflix where we can consume video. We have IPFS that can handle the tracking automatically. But there's a problem, as I've shown you, like with the internet and the current Web 2.0, there's a problem, which means that you cannot authenticate or verify what is happening in these services. So you don't have a way of authenticating the source of the content, and you don't have even a way of authenticating the execution of code over these applications. And that's how the Web3 appears. Actually, the reason why we cannot authenticate, so the fact that we cannot authenticate the source of information and that we cannot authenticate the execution of code is the reason why in many cases we require a third party, like for instance Amazon or eBay, to perform an exchange through the internet. So that's why some people say that from the Web 2 from the Web 3 we're going from the internet of information to the actual internet of value, where we can exchange value through the network. And the reason for this is that we add an additional access right, let's say, to the web, that it's trust. So we will have a way of authenticating not only the source of content that we saw through the content address network, but also through blockchains, we will be able to verify the execution of code within the network. And that's how all of these applications appear. So all of these DeFi applications, stable coins, NFTs, proposals like UBoard of decentralized identity, or what we saw of ION from Microsoft. So all of this is possible because we are introducing into the network the ability of trusting and verifying not only the source of some information, but also the execution of code. And if I had to define the Web3, again, something that I really want you to take from this talk is that Web3 is not only blockchain, it's way more. So it's decentralized storage and many other things, many other protocols that will allow us to decentralize and to make public goods accessible for everyone. And if I had to define in a way Web3, it would be a combination of distributed web, so a web of having a way of working offline, having a faster internet that is content addressed with permanent links and through a decentralized infrastructure, that uses blockchain for publicly verifiable executions so that it's permissionless and everyone has access, and it has some kind of incentive alignment. This example of having a technical layer for the incentive alignment, we see it clearly in Filecoin. So we go from IPFS, where there's no incentives to store content, to adding a blockchain into the IPFS stack, not the IPFS network, but the IPFS stack. So the kind of protocols used in IPFS in order to incentivize storage and have a decentralized storage with incentives, where there's an SLA of the storage of content in service providers. And finally, we have the semantic web. And this is really linked with content addressing, because once we have these unique IDs of content as a first citizens in our data model, it will allow us to create graphs of all of the content that is stored in the network. And this is I may be going way ahead, but it's another really interesting protocol that content addressing networks could have. We could have the everlasting promise of semantic web and having a way of linking content with each other. So in the end, as I said, if you have to take something from this call, is that Web3 is not blockchains, but blockchain is an additional model in the Web3 space. So the same way that we have databases as a key component for the web to build a website, blockchains are a key component to build the kind of use cases and applications that we're looking to deploy over the Web3. And another example of how I like to think about Web3 is that it's kind of open source. So actually there was a huge leap forward with open source, because for the first time we could like openly collaborate on the source code of some big project and make innovations over it. And with blockchain and with the Web3, what we are doing is that we are taking open source to the execution of code, so that we will be able to have open platforms that we collaborate on, and that we would be able to verify that the executions are correct and like build other kind of use cases. Yeah, and here I just shared a bunch of the projects that you probably heard of in Web3, but there are many more. And the idea of Web3 is for it to be a modular, like to be a set of modular projects that we can put together like a Lego and get something bigger and better. Actually, you can also see these. So I'm going to share a bunch of the pieces of the IPFS and Fargo stack. But you can see this example of like having smaller pieces that we bundle together in order to get a better application. For instance, in Ethereum, in the Ethereum ecosystem with DeFi. Like in DeFi, you see like really complex financial proposals based on like stable coins, for instance, DAI, and based on collateralized lending and so on. So there are really cool applications that it just take like one piece of the Lego, another piece of the Lego, and build crazy use cases on top of it. So the idea of all of these like content addressing and all of these stack of peer-to-peer and decentralized protocols is the same, like to have the basic models that would allow us to make more complex applications and more complex projects. And some of the examples of these pieces of the Lego for Web3 are, for instance, like multi-formats, which is a way of future-proofing and like identifying any content in a future-proofed way independently of where it's stored. We have libp2p, that this is the key library for peer-to-peer networking that is used in many applications. It's not only used in IPFS and Filecoin, but for instance, like the Ethereum client for the Bitcoin chain, so what was called Ethereum 2.0, but now it's, I think, the consensus layer. So they're using libp2p under the hood. Polkadot, for instance, is using libp2p under the hood. And there are other cool projects that are not actually even Web3 specific, like Petal ML, which is a way of collaboratively like running big LLMs, like large language models that are now in with ChatGPT so trendy. So there are projects that they are using this peer-to-peer networking in order to do something else that is not Web3 specific. So you can see that this Lego is not only used by Web3 protocols, by Web3 projects, but something else. Then we have IPLD, which is another, like this is a data model that allows us to have links and unique IDs of content as a first class citizen. So the same way that in a programming language we have an integer, we have strings, we have bytes, and so on. This IPLD is a data model that has all of those primitive types, and it adds a CID, a content identifier, as a primitive type in that data model. So whenever you have to handle like data that may be and you're programming over data that it may be decentralized in different infrastructures, this data model is really useful. And these three pieces are just an example of a bunch of protocols that are used by IPFS and Filecoin for its operation, but that many others can use for their own projects and their own applications. And again, like all of these projects are hosted in GitHub and open source, and you can like contribute and change it as much as you want. Cool. So I hope that with this I gave you a brief and not so brief overview of IPFS, Web3, and so on. And now let's go to the low level and like to the hands-on part, where I'm going to share some references of how you can start using IPFS and Filecoin. So one of the first projects I would highly recommend to check out is Textile. because in Textile they have a lot of, they have a bunch of libraries in order to interact with IPFS Filecoin. And if you're a developer and what you're looking is to right away try to develop some kind of use case that you're thinking on top of Filecoin and IPFS, Textile is great because it has bridges with other networks in case you're using some kind of blockchain to run some smart contracts. It's also really cool because it has a way of building like buckets and building some abstractions of storage over IPFS so that you have structured storage. So I think it gives you all of the bare bones that you need to build a cool application over Filecoin and IPFS. But if what you're looking is more to try and test the network and maybe, I don't know, host your first website over the network, the three key projects you have to check out are these three: NFT storage, Web3 storage, and estuary. And the ease of use and like the specificity of the use case for each of these platforms goes from top to down, right? So first we have NFT storage, and in NFT storage, what you have is a platform where you that it's specifically tailored for NFTs, and it allows you to store NFTs in IPFS and Filecoin in a really easy way, and attach some metadata if needed to these to what you're storing or the content you're storing in the network. So, for instance, if we go to NFT storage, you see that maybe I can log in and show you the dashboard, but in the end it's super easy. Like it will guide you through the process of uploading a file and setting up the metadata, and the API is really simple because it's just like push some content and it will be accessible even through the IPFS // that we saw. Hopefully if this loads, I can show you an example. Okay, so for instance, here I have like 2 examples of CIDs. I don't really know what is behind it. So to upload it, you just like upload directories through an application that it's called NFT app in case you want to upload a bunch of NFTs, or you can upload your content. And this will be uploaded to both IPFS and Filecoin. So it will be persisted. Here you see that this piece of content is persisted in 3 storage providers in the network, in the Filecoin network, but also it's automatically provided and pinned to the IPFS network. So that's why we see this pin. And hopefully, if I do IPFS // and this guy, it should load whatever. Oh, okay, and it's an image of me. So you can see an example of some file that I uploaded and that I can access through IPFS by just like clicking this upload button and like uploading some content. So you see, I mean, this NFT storage is a great way of interacting with IPFS and Filecoin really easily, but it's quite NFT specific. If you want to use IPFS and Filecoin for more general purpose applications, but you want still that easy UX and easy dashboard, and you don't want to deploy your Filecoin node or your IPFS node, don't worry about anything, you can also use Web3 storage. And if we go to Web3 storage, you'll see that so let's see if I can go in. The experience is really familiar to NFT storage because you have kind of the same things. You have then you have APIs to do more complex stuff and interact through your library or through your application. But if you want just to upload some files or a website and start testing it, it's as simple as, again, clicking this upload files or downloading a Web3 app application where you just like pick whatever you want and upload it to the network. Again, you see that we have it stored, in this case, in 3 storage providers, and it's provided also through IPFS. And if I copy this CID and I do the same IPFS / and this guy, it should load whatever is behind it. That in this case, yeah, it's an image of some graph that I have. So you see that if we're doing some NFT specific use case, we use NFT storage. More general ones, Web3 storage. Check the documentation. You can also interact through their API, and no need for your application in case you're deploying an application and you want to use Falcon and IPFS as your backend. And finally, if what you're looking is to actually deploy a node, like keep your infrastructure and handle your infrastructure for the in order to store content in IPFS and Falcon, instead of having to deploy a specific IPFS node and a specific Falcon node, if you want to upload content to both networks because you're looking to have the fast capacity of IPFS and also having the reliable storage of Falcon, instead of having independent nodes, what S2RE does is bundling. Actually, under the hood, it's similar to what Web3 storage does and what NFT storage does. So in S2RE, it gives you the infrastructure, so the node that is bundled with all of the protocols for IPFS and Falcon, and allows you to do what NFT storage and Web3 storage does for you under the hood. So actually storing something and pinning something in IPFS through your infrastructure, pinning in IPFS and doing some deals with service providers so that you can store content in the Falcon network. And this is super outdated, but to give you a sense of last year, I don't know, this is probably mid-2022, to give you a sense of the amount of content that was uploaded and the NFTs that were uploaded through these services. You see that mid-last year, there were 53 terabytes. Now it's crazy the amount that has been stored in these networks through NFT storage. We have a similar thing with Web3 storage. In this case, like, you don't have a number because like it's the number of uploads, but content are not specifically NFTs. It can be anything. And this is an example of S2RE where you have like S2RE is more like complex in the sense that it gives you all of the features that you need to do low-level stuff, like creating your own deals and so on, that is abstracted by NFT storage and Web3 storage. But what you want is to actually your application to use all of the low-level primitives of these networks. S2RE is a good way if what you're looking is hardcore style and you want to actually control all of the infrastructure and interact with your network with your own nodes. You could also deploy your own Falcon and IPFS nodes. And S2RE also had some numbers on what is the amount of content that is used by applications. So this is just to give you a sense of the amount of data and the amount of use that these applications and these services have, and that IPFS and Falcon are actually things that people are using, right? So it's not just some science fiction thing that will come in the future, but it's something that you actually can interact with right now. And as we're approaching the top of the hour, and I want to leave some slot in case there are questions, I'm just going to leave you a bunch of references here in case you want to dig deeper into all that I've explained and how IPFS works, how Falcon works, and so on. We have these interactive tutorials in proto.school. So if you go here to proto.school, you'll see a lot of interactive tutorials, both like hands-on and also like more theoretical, where you can learn about like decentralized web concepts, IPLD, Falcon, and a bunch of things that I've been mentioning throughout this stuff. And finally, if what you're more into is videos or consuming theoretical knowledge on a video format, we have also actually some of these slides are taken from that ResNet Lab on Tour, and this ResNet Lab on Tour in the end is just a set of modules and videos, like short videos between 20 to 30 minutes, presenting like how the low-level information of how many of the protocols of IPFS work. So you'll learn things of how content addressing works in IPFS, content routing, how this change of content works, and this can be found in the, if we go to the research protocol.ai/tutorials, I think. Yes, you have this ResNet Lab on Tour. So research protocol AI tutorial/ResNet Lab on Tour, you have like all of these models and all of these videos with some peels of information about some of the low-level protocols of Falcon and IPFS. This is just in case you want to dig a bit deeper into how all of these projects work. And I guess that's all from my side. Thank you very much, everyone, I'm sorry for the initial technical issues. I hope I'm on time. And if we have some space, I'm happy to take some questions. Thank you.
Right. Do you have any questions?
Yes.
Okay. Give me a second. Let me sort out the video. Yeah, I can hear you if you just scream. Go ahead.
Okay. Well, there are a couple of questions that I have, and a couple of issues I have with IPFS. One is you're assuming that the content that people are putting in IPFS web pages is actually immutable, but there's actually no thing to stop people putting in HTML with JavaScript calling microservices, so that in the end the content there actually gets tied in with the other, and you basically just using it as a kind of storage. The other question I have, which I will give after you answer that one, I have another question.
I'm not answering it. He is.
Yes, I know he is. Did you hear the question?
Yes.
Did you hear the question?
No.
You didn't hear it.
Give me a second. Sit down. Yeah. Alfonso, can you hear that? Yes, you can.
Echo.
Sorry, maybe you can write the question.
Oh, no. Now taking him off.
Maybe you can share the questions through the Zoom.
Right.
So that you keep the same audio settings.
Yeah.
Yes,
Okay,
this would be hard.
We needed to. Sorry. Right. Okay. So your question was, basically, you can embed code into whatever you're storing in IPFS, and basically that then just hooks into everything that's going on at the moment. Is this correct?
Well, basically, the storage you're using for IPFS, there is nothing actually dictating what you're putting within that storage. There is actually also no agreements as to what's in the storage. There's neither agreements. The only thing is you just put it in there, and in fact, a lot of the HTML pages that may be in there, can continue to use microservices, which means that basically they're just as mutable as normal web pages, except that the content address is still there. But one of the workarounds was this. But anyway, so the question is any way to actually create a sort of a forced etiquette saying that actually the content has to be self-contained and immutable itself.
Okay. So, you send that through to him.
Because you're having immutable storage, but then the content itself actually is calling in a bunch of mutable resources, microservices. So basically, you're not getting anywhere.
So the question is.
The other question that I might as well just burp out since this is allowed to ask these questions is if one wants to actually search the IPFS, since the DHTs are public, obviously we can eavesdrop and we can see what people are accessing it, but we still don't get access to what people aren't accessing. So it's a bit like the normal standard Google with web, which basically is
Okay, so I see a question around how do you make content immutable itself. So I would highly recommend checking out this tutorial on content addressing, because it shares the protocols behind doing content immutable. But really briefly, how it works is that what it is enforced is that the content so actually it's not the immutable persistence. It's only enforced in Filecoin, and the way that you enforce immutability is that the content identifier is inferred from the actual content. In the end, you do you chunk the content, you do a hash of that content in a special way, and that's how you have a unique identifier for that specific content. So you make it immutable in the sense that if you change anything from that content, the ID will completely change. So that's why it is immutable as long as it is persisted and long-lasting in the storage, and that's why the incentives over Filecoin. But that's it. So in the end, it's just taking the content and doing some kind of hash in order to create a unique identifier that makes it immutable. But in order to be immutable in time, if that's your question, then you actually have to have it stored somewhere.
The point is that
Go on.
let's go to the next question.
All right.
I'm
chat if I answered the question or there are
The other
follow-ups.
question is how does one actually do information discovery other than actually limiting oneself to eavesdropping popular content ideas?
Okay. Same.
Yeah, because in the web we have search. Here we go. Yeah.
Okay, that's a great question. So the question is, how does one do information discovery other than eavesdropping popular content IDs? Because in the web, we have search. And that's a great question. And for that, I will highly recommend, it's too bad I didn't have more time, this content routing module. In the end, there are, so the same way that you receive a URL in the internet, and but someone has to give you this URL to find the content. What happens in decentralized storage and like in the decentralized web is the same. You will get some kind of analogous URL to find the content. And under the hood, when we do this IPFS thing, there are different protocols that are trying to find that content. So we rely on, one example is distributed. So one of the protocols, what it does is just gossip with its neighbors. So you gossip with your connections and you say, hey folks, someone has the content that I'm trying to find with this URL. And if it has it, it will give it to you. And if not, like it will at least give you some pointers of where the content could be if it knows it. This is one example of a protocol. Then we have another one that is based on a DHT. A DHT is a decentralized data structure called the distributed hash table, where you have a registry for each content, what peer has that content. So this is another protocol that can be used to find the content. And then there are other services, like for instance, an indexing service that it's a huge routing, or more than a huge routing table, it's a huge service that keeps track of content and where it's stored, either in IPFS and Fiber. And actually these indexing services are quite new, and they are the way that are being used in order to check when content is available in IPFS or when you have to go to Fiber to fetch it. So in the end, like you have several ways of fetching the content, but the trigger should be the same way that the URL is a trigger to call the DNS service, get the server and do the HTTP interaction. In IPFS, you need a first unique ID of content or a URL in order to trigger all of these protocols that will try to find the content for you.
Any other questions?
Do you think that, I'll talk slowly.
Thank you.
Do you think that IPFS or any file, decentralized file storage for that matter, can actually be censorship free, considering that we as humans have limits to taste and stuff like war footage or snuff footage could end up there. Right now it's not censorship free. They do censor stuff that obviously should be censored. But considering that, do you think it's ever possible to have a completely free?
Okay, so the last question is, do you think that IPFS or any decentralized file storage can actually be censorship free, considering that we as humans have limits to taste? So architecturally and technically, the protocols are censorship free, but of course there are caveats, and an ISP could be, like for instance, like I'm based in Spain, and the Spanish government or the Spanish ISPs may say, hey, if you see this kind of traffic being shared through your networks, just block it. Yeah, so the protocols technically, they are censorship free in the sense that as long as they don't rely on an infrastructure that can be cut, they should be able to find the content if it's available in the network. But of course, there are some caveats, and so we don't control the low-level So in the end, we still need ISPs and we still need a way of like routing content through the internet, and these could be to some extent decentralized. So yeah, like they are to a big extent and to a large extent censorship free, but I wouldn't say that it's the end game. Like there are other considerations to have.
We have now since November in the European Union the Digital Services Act. And the Digital Service Act actually deems content that has to be blocked.
Is there any other question? If not, I will have to jump now. Thank you everyone for your great questions, and
unfortunately
this time I really hope that next time I can be there in person with you all.
I can't take that question away for you.
So hope to see you around.
Okay. Digital Services Act.
Digital Services Act. Okay, fantastic.
DSA.
I'm gonna
Because it's legal peril right now.
Alfonso, a bit of an echo, but thank you so much.
Really appreciate your talk. And yes, we look forward to welcoming you in Munich later in the year.
Thank you, everybody.
For sure. Thank you. Cheers.
Okay, thank you very much, everybody. Now, we have come to the end of our talks. However, I think some of you are like, hey, I just mined all this crypto. What do I do with it? So, for those of you who want to continue the workshop, you're welcome to stick around. For everybody else, you're welcome to network, enjoy the food. There's still quite a lot. There's quite a lot of water to drink. Yeah. Let's see how well you can do. And yes, just enjoy the rest of the evening. For those who want to do the workshop, if you just come a bit closer, and then the thing is I will walk you through how you do the applications, and then you will get your first taste of actually using blockchain rather than just hearing people talk about it. I will tell you that it changed me forever when I did. So yes, thank you so much for coming, and I look forward to welcoming you online, I think it's February 9th, for another set of talks. And then we'll be back to Munich. We should be back in March. I think it's March 24th that we'll have another in-session in Munich. But you're all on the email, so I'll keep you updated with respect to that. Thank you so much.
The Digital Service Act actually demands
Who wants to do the workshop?
Doesn't matter what kind